In this video we're going to be looking at basic sine and cosine functions. I think we'll just do the sine in this video, and then part 3 we'll do the cosine. In this equation, y is equal to sine theta, we can think about the y as being the output. It's still going to be the y-axis here. And then theta, that's the input. This is the theta axis. This is also the x-axis, except in this case we don't have an x, we have theta. Keep in mind the inputs are still on the x-axis and the outputs are still on the y-axis. Let's make a table of values and see if we can figure this one out. So we'll do theta over here and then y over here. This is usually done with radians, but it totally can be done with degrees. It's just a unit. So when theta is 0, we're wondering what the y output is. Well, to find the y output, we just have to take the sine of 0. If you're using your calculator, then make sure that you're in radian mode. For the 0 it doesn't really matter, I suppose, but just make sure you're in radian mode for this. And you can hit the sine of 0. You'll notice that it's 0. If you're using your unit circle to understand this, then you would also have a y value of 0 at 0 radians or 0 degrees. So when theta is 0, the output is 0. We can plot that point. A normal, regular y is equal to sine theta or y is equal to sine x begins here at the origin. As we move on to a next value, we've got pi over 2 here. And you can find all the values in between, and we might do that here in just a little bit. But there's usually 5 values that you should find. 0, pi over 2 pi, 3 pi over 2, and 2 pi. So we know that pi over 2 here, to find the y value, we can just take the sine of pi over 2. Some of you who are using the unit circle know that the y value at pi over 2, which is also 90 degrees, is 1. Let's see if our calculator agrees with that assessment. So we can just do the sine of pi divided by 2 and hit enter, and it is 1. We can plot that point. The input is pi over 2 and the output is 1. The next nice angle to use here is pi, and you'll note that the sine of pi, or 180 degrees, is just 0. The coordinate would be negative 1, 0, and the y value is 0. You can double check your work if you want. Type in the sine of pi into your calculator, and of course we get 0 degrees. Or excuse me, we get 0. 3 pi over 2 is the next angle, that's 270 degrees. And we forgot to plot pi 0, so pi 0 is right here. And 3 pi over 2, the sine is going to be negative 1. If you looked at your unit circle, you would see a coordinate of 0, negative 1, and the sine is y over r. You can also double check your work by typing in the sine of pi, 3 pi divided by 2. And you'll note that it's negative 1. So all we're doing here is we're building a table of values and plotting the points. 3 pi over 2 is negative 1. As we go around to 2 pi, well, that's really the same as 0, so the output should be the same. One of the cool things about these trigonometric functions is, at least for the sine and the cosine, they're periodic. We'll investigate the other ones a little bit later. So these values will just repeat. We can now try to draw this curve. If you need more points, you can totally draw more points. Pi over 4 would be right here, and you can ask your calculator to evaluate the sine of pi over 4. It's root 2 over 2, an exact value, but I think here it's going to help us if we have some decimal approximation. So we could do the sine of pi over 4, and that's about 0.7, maybe 0.71, but I think 0.7 will do for us. So we'd go to pi over 4, and then up about 0.7. That's 0.75, so maybe that's right in here. You could plot a lot of the values all the way through. You're going to find, if you do though, that they form a curved shape. Some of you may notice that this appears in nature a lot. It also appears in tides. It appears in the hours of the day. Lots of weird places this sine curve shows up. If we kept plotting this, this is one full period, but these values will just repeat as we go around the circle. So you can imagine that if we went up to 1 at pi over 2, that here we would go up to 1 at 5 pi over 2. You can verify that if you want. You can type in sine of 5 pi over 2. It's totally 1. I'm just going to use an arrowhead here. If you're not asked to graph over an interval, just use an arrowhead, meaning that it keeps going. And then here as we go down towards negative pi over 2. Key points of this are that the basic sine curves begin at 0, 0. They begin and start upward. At pi over 2 we have a y value of 1. They come back down, and at pi we've got 0. 3 pi over 2 is negative 1, and 2 pi is 1. And then after that, all these values just repeat.